So that takes care of that. So we have a couple more here. We have this strafe right here. We also have this projectile attack. Let's go ahead and work on the strafe logic now. So of course, as always, set our AI states to stop brain. And so strafing can be a little tricky. First thing we need to do, we need to get actor location. We also need to get the right vector. We need to get actor right vector. There we go. Okay, so for strafing, it's actually going to, this is like another thing we're going to use on the tick event. So let's go ahead and scooch this over and let's create a sequence node. I'm going to scooch all this over a little bit. And then I'm going to create a new variable here, and we're going to call this one strafe. Okay, so for strafing, what we need to do is add a movement input. Let's go ahead and plug that in here. And I'm going to scooch this down a little bit. And I'm going to go ahead and collapse this into a node as well. Collapse nodes. Look at target rotation. That way we have a little bit of space to work with here. I'm going to move this down a little bit. Okay, so for strafing, what we should do is we should probably create a new enumerator to kind of define which direction the AI should strafe in. So if we go to our folder, here we go. Let me clean this up a little bit. Let me add animations. Move that in there. So let's go ahead and create a new enumerator by going to Blueprints, Enumeration, and then we'll call this one E strafe direction. Okay, so typically there'd only be like 3 different directions an enemy should be able to strafe. We'll do left, we'll do right, we'll do back, and that should do it. Now let's go ahead and import that new enumerator into our AI. We'll call it strafe direction. Here we go. So let's go ahead and add this in. We'll do a switch. Actually, we're not going to set this here. I think we should set this in our make decision. Here, let me copy this. And so essentially what we should do is we should have like a percentage chance of the AI strafing. So we can add that in before this move to target. So put that in here. Okay, let's go ahead and delete this actually. What I want to do, we're going to do random float and range. Okay, same thing, 0 to 100. We'll do less or equal to, and then we're going to promote this to a variable and call it odds to strafe. And I'm just going to assign this a value for testing. Oh, we'll say 30%. Okay. So if it's true, we can also do a randomization for which direction our AI should strafe. Let's do random integer in range. And so since we know that there's 3, that means if we're starting at 0, we can set this to 2. And then we'll do switch on integer. And then we'll add slots for 0, 1, and 2. And then now what we can do is we can set our strafe direction to each one. So we got left, we got right, and we got back. For this one, I'm just going to focus on left to right for right now. So I'm just going to go ahead and plug that into here for now. And then we'll return and work on the back. And if he is going to strafe, then he's obviously not going to attack. So we'll plug that into the false. But lastly, we do need to define how long the AI should strafe for. So now we'll do random float in range. You'll notice I use this quite often. So what we can do is we can set a minimum and maximum time that the AI should strafe. So if we right click on minimum, we'll do minimum strafe duration, max strafe duration. And I would say a minimum of 1 second and then a maximum of like 3.5 seconds. And so we can just promote our return value to a variable, and we'll call this strafe duration. And we'll go ahead and plug all these into it. And then once that's set, we can do strafe for the AI states. That way it switches to it. Okay, so now that we have our strafe direction set, once we switch through here, what we can do is get right vector, get actor right vector. I always forget that. And then we're going to multiply, and then we're going to promote this to a float, and then we're going to set the strafe vector that we created earlier. Let's go ahead and out of our strafe direction, we'll do a switch. So I believe if we're going left, we would want to, let's go ahead and convert that to a float. I'm going to times it by 1. And then for right, we'll times it by -1. And then also make sure that it is plugged into the right vector. And so now what we can do is we can set our strafe variable to be true. And then, I don't even know why I'm keeping these. What we can do, let's go ahead and set our back into there as well. Actually, let's go ahead and just take care of the back one right now while we're at it. We'll duplicate our strafe vector for the back. And then instead of right vector, we're going to get actor forward vector. And then we're going to times this by -1. So if we pull out of here, hit multiply, convert this to a float, times -1, because -1 would be opposite of the forward vector. Okay, then we set our strafe to true. Let's go ahead, before we forget, let's go back to our make decision and then plug it back in here, and we're going to set this to back. So we get left, right, back. Okay, so now what we need to do is set our delay duration, or get our delay duration that we created. So strafe duration, we're going to plug that into the delay. And then once that's finished, we're going to turn this off. And then lastly, we're going to have our AI make a new decision. Actually, instead of make a new decision, because they're strafing, they're most likely going to just attack the player. So what we can do is just do move to target. So we'll compile that. And then out of our event tick, where our strafe boolean is, let's go ahead and plug in our strafe vector. Let's go ahead and force it to go. And then most likely what we're going to want to do is also set our look at target to be true. Because if they're not looking at the target while the movement input is going, then they're not going to strafe around the character in a circle. So let's go ahead and set this look at target to be true as well. Okay, so there we go. Actually, now that I'm thinking about this, I think there's a different way I want to approach actually doing this. So what we should do is this. Okay, I'm going to get rid of this strafe here. Let's see. Okay, here's what we're going to do. We're going to duplicate this acceptance radius. And so we want this to be quite a bit further away than attacking range if he's going to be strafing around the character. So let's set this to something like 450, right? And then we can just plug this straight into the move to target. So we're defining a strafing distance. And then let's create another boolean here. We're going to call this should strafe. And we're going to set that true. And then I'm also going to copy the should strafe and then set this false here. So now, whenever we go to move to target, we've randomized whether it should strafe or not, or whether it should strafe or it should attack. So now if we go to our move to target, once it has reached the destination, if we create a new branch here coming out of the on success, and if should strafe is true, whoops, then we can switch the AI state to strafe. So there we go. And then whenever the AI decides to move to the target again, because we set this false here before it moves to the target, if they're going to attack, then it's going to just reset the should strafe. Okay, so we've done a lot of logic. Let's go ahead and test it out real quick. Okay. Strafing, but that wasn't exactly what we wanted, was it? Okay, give me 1 second here. Okay, so the first thing I realized is that we don't need to multiply this by 1. We can just plug that straight into that. And then the next thing what we should do is I forgot that, like, whenever the character is moving to the target, it's already setting to look at the target, so we don't need to set that again here. Okay, what I'm going to do is I'm going to move this strafing logic to the event tick. Here. Okay, what I want to do is here we're going to get rid of the look at target, and then we're going to set should strafe false. And then lastly, instead of move to target again, we're actually going to do make decision. Okay, now let's try. Okay, now we're back in business. Now I think what I need to do is I just need to set that strafe value to be a little less often. So we'll move this odds to strafe down to something like 15. And then also we should do, if the AI is too close to the character, they shouldn't strafe. So what we can do is, with this get distance to node right here, we can do if the player is greater than or equal to our strafe range here, then they should be able to strafe, and if they're not, then we're just going to bypass it and only do attacks at that range. So let's go ahead and set a parameter for this. If they're greater than, I believe we set the strafe range to be 450. So if they're greater than 440, then it sets a chance to strafe, just like that. Okay, so let's go ahead and clean this up a little bit. I'm going to go ahead and collapse our strafing logic into a node. Call it strafing. And then same thing here. Collapse strafing logic. Okay, so there's a couple things we should do before we go any further. So what if the AI gets, attacked by the player even though they're out of range? We should probably make it so that the AI can then start targeting the player. So if we go down to our damage right here, we could do, what we can do is we get our damage causer. We're going to ask actor has tag player. So if our actor has tag player, and in this instance, whatever projectiles you find, you want to make sure that you set the damage causer that's coming from the apply damage node as the owner of the projectile, which would be the player character. So you would want to set a reference inside of your projectile blueprint when it gets spawned. And you can do that easily, like, let me just do this, give you a quick example. So if we do spawn actor from class, let's see, I'm gonna do this, right? So if I were to spawn this projectile actor, what I could do is inside of this actor, I could create a variable for the character, which would just be an actor variable, right? It would be the same as, oh, actually that's a pawn variable. But what you would do, here, let's just do it real quick. I'm going to go to my projectile base. And then, so, obviously this is set up on a different train of logic for my game. But for your game, if we do the apply damage, inside of your projectile blueprint, you would just create actor, create an actor reference, and then you would want to make sure that this is set to instance editable and expose on spawn. And then you would want to make sure that this actor is plugged into your damage causer, right? And so if we go back to our AI here, and I'm going to go ahead and refresh this, now our actor will show up here. And so whenever you spawn this projectile inside of your character, you would just set the actor to be self. That way, whenever it does apply the damage, it's going to come through here. And then you would also want to make sure that your actor has a tag named player inside of it. And then once that happens, if the actor has taken damage and, it is valid, it is a player, what we can do is switch our AI state to we wouldn't want to do make decision, because if they're shot at from out of range, what we would want to do is face target. That way, whenever the AI faces the player, if we go to our face target here, it would then Oh, so it's actually going to make decision. What we could do here, okay, instead of facing the player, what we could do is we could just simply do move to target and then make sure that we set our target as the damage causer. Oh, well, this is actually a pawn variable, so there's ways to handle this. What you could do is you could do a simple cast to your character. So in my instance, it would be player character and then you would plug it in this way. But you would also want to make sure that once it is set to move to target, that we also plug it into this so that it can determine this other logic here. Like if they should play hit reaction or if they should dodge. So for this video, I won't be going through all of the process of setting up an animation blend space for like aim offsets whenever the AI is actually shooting at the player. I might do that in another video, but I will show you how to do everything else for it, like how to fire the projectiles and all that. So what we can do, I'm going to create an arrow component. Here we go. And then for this, I'm just going to move it up a bit. But essentially what you would do is inside of your gun mesh, whatever it is inside of your actor, you would essentially just make it a child of it, and you would attach the arrow to the socket of your gun, right? So over here, if we go to sockets with the arrow component selected, we could select a socket for it to attach to. I'm just, for this demo, I'm going to do the head. And then if we like zero it out, it'll actually snap to where the head is. So I'm just going to move it like right here. So what we can do now is we get our arrow component. We're going to get world transform. So we know where the location and rotation of this arrow is at inside the world. Then we're going to spawn actor from class, put that into the spawn transform, and I always for projectiles I do ignore collision, always spawn. We want to make sure to set our state to stop brain. And so we're actually going to put this in a different location. First, actually, let me find a projectile to fire. I'm just going to do this arrow projectile that I already have in my project. So we're actually going to disconnect this and we're going to create a new timer. So we're going to do timer by event. And then we'll do looping. I'm going to do 0.15 looping. And on this event here, custom event, I'm going to call this fire projectile. And so it's going to loop fire in this like an automatic weapon. We also want to define the duration that they should fire the projectile at. So we would probably do that in the make decision. So this is our strafing range. What we could do, we can make the strafing range the same. And so if it doesn't strafe, here, tell you what, we'll make like a medium range here. So if it's less, if it is closer than 400, honestly, we should probably do our strafing range. Sorry for the cough. We should probably set that at a further distance for projectiles. So I'm going to do is greater or equal to, promote this to a variable. We'll call this projectile range. Let's do something like 600. So if it's greater than 600, then we can roll a chance for it to fire projectiles, right? So we'll do random float in range 0 to 100 less or equal to, promote this to a variable. We're going to call this odds of firing projectile tiles. And then we'll set this to something like 25%. Okay, and then if it fails the odds, then it's just going to continue on with the rest of the logic. If it doesn't, oh, we actually copied the wrong thing. We're going to set the state here to fire projectiles. Now, there's actually one important thing that I forgot to implement, and we should probably do it before we continue on, and that is to basically stop the AI's movement whenever it's performing certain actions. And to do that, let's just create a new event out here. Call this stop movement. And this is super simple. We're just going to do AI move to. Set the pawn as self. And then we're going to get actor location. And essentially just set its location to itself. That way it stops immediately. And so we want to stop the movement. Let's think about this. We want to stop the movement whenever we are making a decision. Let's go ahead and copy that. We would also want to do it whenever the AI dies, right before it plays the animation. As well as hit reaction. And then lastly, we'd probably want to do it whenever it turns to face the player. Okay. And we probably want to do it here when it's firing the projectiles. And if you really wanted to, you could even set it so that whenever the AI is firing projectiles, you could have them strafe for a duration. So let's see. So we stop the brain. We're going to get random float in range. We're going to set this to minimum projectile fire time. And then max projectile fire time. Let's go ahead and assign some values to it. We want to probably minimum of like 2 seconds. And then a maximum of 3 seconds. So we're stopping the movement. We're setting a duration for it. So let's go ahead and promote this to a variable. Projectile fire time. We want to make sure to promote this timer's return value into a variable so we can stop it. And we're going to do fire projectile handle. So after this, we're simply going to add a delay. We're going to get our projectile fire time. Then we're going to get our projectile firing handle, and then clear and invalidate timer by handle to stop it. And then after that, we can tell our AI to make a new decision. And then if we wanted our AI to strafe during that time, we could do set our strafe to true. Yeah, buddy, I know. My cat. Set our strafe to true. We also want to do set look at target to true as well. Should probably do that before the strafe. Cat, forget it. Okay, and we'll copy these. Paste them down here, and then we're going to turn them false. And that might be all we need to do for this. Let's go ahead and collapse this. Call it fire projectiles. And then for the sake of testing, I'm going to set this odds to fire projectiles to 100%. Okay, so real quickly, just so we can have a little more control over everything, I'm going to go through the project and I'm going to create variables for specific things inside of our data asset. That way we can just set them all here, and then it takes effect inside of our AI. We need one for projectile range and odds of firing projectile. We also need strafe range, which is set to 440, and odds to strafe. There's one that I didn't create, but we should create, which is a strafe acceptance radius. Okay, we need one for dodge distance. And what we can do inside of the blueprints here, for the dodge distance, since we're setting it to a value before here, is we can take our dodge distance. Oops. Get dodge distance, and then for the negative, we would just do times -1. And this will actually be a different variable. We should name this a different variable because this dodge distance is being set here and used here, and then this is the one that we'll be pulling out of our data asset and naming that way, and it should be something different. So let's go ahead and delete this. We'll promote it to a variable. Dodge distance data. And then we'll just plug it normally in for the regular dodge distance. Okay, we need ones for minimum projectile fire time and maximum projectile fire time. Okay, I believe that's all of them, so let's go ahead and set those up inside of our function called setAIVariables. Okay, it should all be set up now. And now we have full control over all of our variables inside of our data asset here, which is nice. So whenever we create a new AI and we want to just tweak variables to our specific liking, this is all we need to change. And just make sure that you set it as our AI data over here. So another thing that I would like to add is I think our AI is a bit slow at the moment, walking at 300 for its max walk speed. What I want to do is create something that will speed up the AI speed as it gets closer to the character. So what I can do, or what we should do, let's create a new event. And we're going to call it increase speed. And then we're going to grab our character movement components and then search for set max walk speed. We're going to create a timeline. We'll call it increase speed. Oh my goodness. Increase speed timeline. Let's go ahead and open it up. Length to 1. We'll add a float. Alpha. Set to 0. And 0. Create a new one. We're going to set it to time of 1. Value of 1. And then for this, we would probably want to leave it like linear. Like, you know, a solid linear increase of speed over time. And so with that done, let's search for a lerp, just a regular lerp, and we'll put that into our alpha here, and then we'll plug the return value into our max walk speed. And then we will play from the start. Actually, you know, we'll do just a straight up play, because it could be at a different value at a certain point, and so it would just go from wherever value it is currently at. So what we can do here, so we'll do a variable for start speed, which is a float, and then we're going to create one for target speed, or actually max speed. And so the start speed would essentially be just whatever it is currently at the time. So we'll duplicate our character movement component. We'll get max walk speed. We'll set that as a start speed. Actually, I changed my mind. Let's plug this back into play from start. Okay, so now inside of our data asset, let's go back to it. I actually need to open it. Go here, DAAI. So we'll do start speed. Since we already have a default movement speed, this will be something different. And I'm going to put it underneath here. Make sure it's a float. Actually, the start speed is, what am I thinking? It's actually determined inside of the blueprint itself. So we're just going to change this. Instead of start speed, we'll do target speed or max speed. There we go. And so I'm thinking we probably want them to go pretty fast. I'm assuming something around 800 would be decent. And whatever we set in here as the default of the main data asset, it will also show up as a default inside of our created data asset, which is right here. Well, that's actually health. Here it is, the max speed right here. And then let's go ahead and create another one for speed increase duration. And I'm going to put that underneath max walk speed. And then let's say I want it to increase like 2 seconds to increase the speed. I'm going to set that as the default. And then we're going to do the go back to our AI. Do the same thing inside of our AI variables. We're just going to go to the end here. We're going to grab our increase speed timeline. we're going to set play rate. The same thing that we did for these over here. We actually don't need those to be right there. What we can do, we'll hit divide on this. 1 for the top value. And then we're going to go ahead and get our increase speed duration, promote it to a variable, and then plug that into the bottom of our divide. Then we also need to get the max speed, and then set max speed. Okay, so now let's go ahead and call that increase speed that we just created, and we want to do that whenever we're moving to the target. So right after this look at target boolean, I'm going to call increase speed. Let's get our character movement components here. Let me go back to the event graph and go back to our make decision. So whenever we stop movement on make decision, we can also reset our max walk speed to our, there we go. Okay, so let's quickly set up some death animations for our character. That one's a little dramatic. Okay, that one's not too bad. We'll go ahead and retarget this one. Okay, let's go ahead and create a montage out of it. And then we'll add that montage to our death animations array inside of our data asset. So now, oh, one thing we should probably do, I'm going to open this back up, is whenever the character dies, we want to make sure that they stay dead on the floor, and we can do that by creating a montage section. So if we right click in this top area over here, we're going to hit loop, or I'm going to type in loop, and I'm going to drag it to the end. And then over here you'll see a tab that says montage sections, and we're just going to set that to loop. So if we hit play, it reaches the end and it loops there at the very end. And that should do it. So I'm going to lower our character's health a little bit. I'll set it to like, I don't know, 300. And then we're going to see if it works. Works. Oh, he's still trying to move though. Oh, you know what's possible is that he's trying to strafe. He could have been starting to try to strafe or something. So let's go ahead and set that to false. We could also do set look at target to false as well. Okay, so now let's check and see if that fixed our issue. So if you saw there, it was starting to play it multiple times. Pretty funny. Okay, so what we should need to do is on death, before the death boolean, we need to create a branch, and out of the false pin, we're going to connect it up to death, and then we're going to get death, plug it in so that it can only happen one time. Actually, where we need to plug this in at is at the very beginning of the take damage. So I'm going to reroute this, plug this in here, go ahead and compile it, save. Okay, so yeah, if we look here at the add movement input, we have this scale value just set to 1. So let's go ahead and promote that to a variable. We'll call this strafe speed. And of course, like always, go to our data asset, create a variable for strafe speed, go into our AI, in our set variables function, and then let's go ahead and set a value for it. I'm going to do like 0.5. Oh, and then now that I think about it, whenever I know it's happening, whenever the AI is moving to the character, it is set to, it calls that event where it increases the speed. So what we need to do is create another event which stops that speed, and then maybe we can even set it as the default value. So actually, I'm going to bump this up to like 0.7 here. We're going to go to our AI. I'm going to go here. I'm going to create a custom event. We'll do stop increase speed. And then whenever starts strafing, stop increase speed. And we can also do get our character movement. And then now I'm realizing we shouldn't set the strafe speed on the event tick, because this is just setting the controller input to a scale of 1. And what we need to do is for our strafe speed, we need to set that here for the character movement. Okay, let's go into our data asset and make sure that our strafe speed is reflective of how fast we want the character movement to move at, and I think that would be, I would probably put it around like 270 or 280. Fell off a cliff. Okay, so that's something we should probably address. Okay, so there's a couple ways we can handle this. What we could do is we could create another arrow component that is directly behind the character and have it fire a line trace directly down, or we could do it with math. And for the sake of simplicity, we're just going to do it with an arrow component. So I'm just going to make a new arrow component. I'm going to call this edge or cliff detection. I'm going to make sure that this is attached to the capsule. Move it over here. And I'm going to point it downward. So once the strafing has started, what we can do is we can create a new event, and then we'll do cliff or trace for cliff. We're going to grab our arrow components. Oh wait, this one. We're going to, let's see. We're going to do get up vector. There we go. So we'll do get up vector. We're going to also get world location. And so out of the get up vector, we're going to multiply it. We're going to convert the pin to a float. And then I'm going to set this to a negative value, say something like negative 600. And then out of our world location, I'm going to add, and then I'm going to add these together. Then I'm going to right click, line trace by channel. I'm going to set the world location as the starting point, and then the added values as the ending point. I'm actually just going to scooch this down here too, because what we're going to do is we're going to create another timer. Set timer by event. Oh, I don't know. I'm going to do like 0.15 or something. I'm going to promote to a variable. We'll call cliff timer handle. Of course, we'll do looping out of the event. Trace for cliff. Okay. Cliff trace. There we go. Going to pop that in there. Okay, and so now what we're going to do is we're going to break the out hit, pull out and search for break, hit result. We're also going to create a branch and hit and add the return value to it. And actually, I don't even think we need this break hit result. All we really need is if it hits the ground, we know that it's good. And if it doesn't hit the ground, then that's when we would want to stop the movement. And then we would also want to do make decision. Okay, and then last thing we would want to do is if it doesn't detect it, then we're going to stop this timer. So we'll get the cliff timer handle. We'll do clear and invalidate. Timer by handle. Okay, so that should take care of our cliff issue. All we need to do is call it now. trace for cliff.